Hi guys, I'm going to discuss Appendix A1 today, basic operations of matrices. It is in page 622. Here we discuss about matrices, right? You will see applications later. The definition of a matrix is it is a rectangular array of numbers, which means I give you simple example 3 4 2 1 0 -2, right? So it's a array of numbers. Now we define the dimensions of this. Before that I tell you these are called rows. How many rows are there? 2 rows. And how many columns? 3 columns. So we say the dimensions of this matrix is row number times number of columns. Number of rows is 2, number of columns is 3. This is a 2 by 3 matrix. That's what this means. Dimensions are given by number of rows times number of columns. Now we want to say refer these elements. Now for instance, how you ask where this 4 is. Imagine you call somebody and read this matrix. Okay, the second element is 4. Then he may wonder this second element or this second element. See, from top 1 2, from top 1 2. So there should be a way to refer that, like XY coordinate system. There we use the addressing method X coordinate first, a standard, right? Likewise here, when we refer these elements, we always say row number, then column number. Row number, for instance, in case of number 4, it is in first row and second column. Therefore 4 is 1, 2 element, right? In here, say this is matrix A. There in A, in matrix A, 4 is the first row, second column, 1, 2 element. Alright, 4 is 1, 2 element. How about -2? It is 2, 3 element. Likewise, this is 2, 1. This one is 2, 1, right? Okay, that's how we refer these elements. We call these are elements, or sometimes we call them entries. Row entries or elements we refer as row number and column number, right? Okay, now there are few definitions. We define the matrix. Now we define some of the properties of matrix. If matrix, in short, I wrote mat for matrix A equal to matrix B, then A and B should have same size, dimensions, they both the same. They both the same. If matrix A equal to matrix B, then their dimensions should be the same. Now what this definition saying is, if the size of matrix A equal to size of matrix B, size of matrix A equal to size of matrix B, then A and B should have same dimensions. In short, you may remember this as size is same as dimension. In short, you may remember this as size equal to dimension. Right. Now, second thing, two matrices of the same size are equal if and only if their corresponding entries are equal. If okay, this is the second thing. If two matrices are equal, corresponding entries are equal. I'll give you simple example. if A equal to 2 1 3 4 and if A equal to B, then we can say B also should have the same element and same size, 2 1 3 4. If two matrices are equal, their sizes should be the same and their corresponding elements are equal. Number 3. Two matrices of the same size may be added. Their sum is a matrix with the same dimension. Each entry in the sum is obtained by adding corresponding entries of the matrices summed. Okay. That means let's do an example. Say A equals to 2 3 1 negative 1 0 5. B equal to 4 2 0 negative 2 3 negative 1. Okay, these are two matrices. How we add them? To add them, their sizes should be the same. See, what's the size of this? This is 2 by 3. This is 2 by 3. Never write 3 by 2. Always row first, column second. Right? 2 by 3, 2 by 3. If you want to add, then A plus B equal to, you add corresponding elements, 1 comma 1 with 1 comma 1, 2 plus 4 6, 1 comma 2 1 comma 2, 3 plus 2 is 5, right? This is about addition. Notice this is of 2 by 3, 2 by 3. The size of A plus B also of the same size. 4. To multiply a matrix by a number calls a scalar. Okay. This is about scalar multiplication. Scalar multiplication of a matrix. Let me explain this using a simple example. Say if example, if A equal to 2, 4, 3, 6, then if you want to multiply this A by any number, say if you want to find 3 times A, 3A equal to, you multiply each element by 3. 3 times 2 is 6. Always think about size. This is a 2 by 2 matrix. As a resultant, we get a matrix with the same size, 2 by 2. Right? Number 5 is about zero matrix. Zero matrix is a matrix whose all elements are 0. Again, example. This is a zero matrix. Or this one. This is a zero matrix. But the dimension of this is 2 by 3. This is 3 by 2. But this is a zero matrix. This is a zero matrix too. See, dimensions are different, but they both are zero matrix. It could be 2 by 3, 4 by 3, 4 by 5, 3 by 2. If all elements are 0, it is a zero matrix. Okay, that's all about definitions in this section A1. Let's do some examples. Example 1. Given A equals to x minus y 5, 7 x plus y, and B equal to 9, 5, 7, 11. Now question asks us to determine x comma y. find x and y. Right. Now if these two matrices are equal, that means x and y, if a equal to b. Alright, if a equal to b, we can say if a equal to b, then a is this, b is this. X minus y, 5, 7, x plus y equal to 9, 5, 7, 11. Right. Now if these two matrices are equal, their corresponding elements should be the same. Now notice one thing. This has variables x and y. This has variables x and y. Right? These are constants. Here they all constants. Notice where they have constants, these constants are the same on the second matrix. Otherwise this question is wrong. You see 7, 5, 7, 5. Right? So corresponding elements should be the same. So we can equate other two elements which has variables x and y. X minus y should be equal to 9 and x plus y equal to 11. Right? Now we can solve these two system of equations. If we add them, we get 2x. Say this is 1 and this is 2. 1 plus 2 gives us 2x equal to, these two cancel out, 20, and x equal to 10. Substitute this 10 in one of the equations. Say if you substitute in 1, substitute in 1, we get x is 10, 10 minus y equal to 9. This gives us y equal to 10 minus 9, which is 1. Right. Now to check, you may substitute 10 and 1 here. 10 minus 1 is 9. Right. So this element is same as this. Check this one. 10 plus y is 1. 10 plus 1 is 11. Therefore our answer is good. X is this and y is this. Okay, next question. I'm gonna erase this. a plus b if a equals to b equals to the question asking us to find a plus b. Question is to a plus b. First check their sizes. This is 2 by 3 and this is same size. I told you if their sizes are different you cannot do addition. Now when we adding, what we do, we add corresponding elements. A plus b equal to 1 and negative 5 is negative 4, 2, 3 and negative 3 cancels, 0, 2 is 2, 9 and 12 is 21, 13, 0 is 13. Right, now the size of this dimensions should be the same, 2, 3, 2 by 3. In answer you don't have to show these dimensions, but I'm showing is their dimensions to show you to add their dimensions should be the same, and also the resultant has the same dimensions. This won't be same in case of multiplication. You will see that therefore in addition, whatever the operations you do, just keep track, check their dimensions. In case of addition, their dimensions should be the same. Okay. Find 3a if a equal to we can get simple matrix 2, 3, negative 1. We should write comma. Five, negative 2, negative 2, 1. Right. 3a is equal to 3 times a is 2, 3, negative 1, 5, negative 2, 1. What you do is you multiply all elements by 3 outside. So we get 3 times 2 is 6. Okay, now this is a scalar multiplication, right? There, let's check the size. This is 2 by 3, 2 by 3, 2 by 3. So resultant should of the same size as the given matrix. But when you multiply into two matrices, it would be different. I'm gonna discuss that in next video. Now let's see what else here. Now with this we see it is just like adding or multiplying regular numbers, right? Means I'm gonna erase this, which means something like this: a plus b equal to c. Now if you want to find a, you simply minus b here, minus b here. But in case of matrices, we have to write it in the same side. If you're writing left of the letter b, you have to write the same thing on left to this element. A plus b, we minus b equal to c minus b. Now we saw when we do this, it is the zero matrix. A plus z equal to c minus b. If you add zero matrix to any matrix, it gives us the same thing. Then A equal to C minus B. It is just like adding, subtracting regular numbers. When you adding 0 to any number, it gives us the same number. Here if you add 0 matrix to any matrix, we get the same matrix. Let's do an example. If half x plus Now we can do this. We have on the left side we have half x plus 1 negative 2 3 0 9 13. If we subtract this matrix on both sides, we can get half x. Let's do that. Minus the same thing I'm writing here, 1 negative 2 3 0 9 13 equal to negative 5 4 negative 3 2 12 0 minus second matrix I write here, this matrix 1 negative 2 3 0 9 13. Then this matrix minus same thing, it is the 0 matrix. We don't have to write that, so we get half x equal to this side negative 5 minus 1. We have to subtract corresponding elements. Negative 6, 4 minus negative 2 is 6, minus 3 is again negative 6, 0 minus 2, 2 minus 0 is 2, 12 minus 9 is 3, 0 minus 13 is negative 13. Right. Now to find x, we can multiply both sides by 2. That's a scalar. Maybe find a different color. Let's multiply this by 2. Multiply this by 2. Then this 2 to 2 cancels out. We get x equal to negative 26. Therefore we get this answer, and this is the answer for x. Yes. Now still it is nothing hard. Adding two matrices, subtracting two matrices, multiply by a scalar, everything just behave like regular numbers. When we involve with multiplication between two matrices and so on, it will be a little bit different, right? Therefore be familiar with this stuff. Now you may check if these are right. You may very confident about this stuff, but in future, means with the next lesson, uh, the stuff are uh, not easily seen, right? There we going to use calculators also. For that you should be comfortable with your calculator. For that I'm gonna show you how to enter a matrix to the calculator so that you may do these questions on your calculator, so you will be familiar with it, right? I'm gonna erase this. For instance, let's enter a matrix. Say we want to enter -5, 4, -3. Say we want to enter this matrix to the calculator, right? And name this as, let's give it a name, say capital A, right? But in calculator you don't have this capital letter. For that we have to enter this as a simple letter. Now let's see how we enter this to the calculator. When you entering, use this, go to the home page, then go to the home menu, then enter this square bracket -5, 4, -3. After you enter first row, do semicolon, second row, 2, 12, 2, 12, 0, finish second row, semicolon, do the third row, 10, -1, 3. After you enter everything, close this, then you press store button, you don't have capital A, say you enter simple letter, say A, right? Now this stores these matrices in the memory called A, right? Now if you want to do any operation with this matrix, say if you want to multiply 3 times A, you simply in calculator, what you should do is, once you do this, it is enter to the calculator in memory location A, you do 3 times, put in home page, you type this 3 times simple A. This gives you the answer, right? This is on the calculator, right? So practice few examples that we did here using the calculator and be familiar with it. We will proceed to Appendix 2 in the next video. Alright, thanks, take care guys.